welcome back to the channel and welcome back to this series. I bet you thought that this was over, but turns out that it's not really quite over. Let me go ahead and flip over to another screen and I'll show you why I've decided to go ahead and do a third part and why I've decided to go ahead and do it as a video as opposed to a live stream. So let me go ahead and flip over here. This is the temperature graph from Octoprint. So what you can see here is that the hot end is really fluctuating. It's going up and down by about 2 or 3 degrees, and what I found out during printing is that this was actually causing the extruder motor to skip steps. Yeah, so I want to take care of that, and I think I have an idea on what that is. Let me go ahead and flip over to my browser here. Come on. Okay, so let me flip over to the firmware here. So what I think we've got going on here, and this is something that I knew about when I built the firmware. I just copied the example configuration for this particular printer from the Marlin examples. So if we do, let's see here. Give me just a second here. I'm gonna flip to the right keyboard. Oh, come on. Let's try. Okay, yeah, there we go. Okay. So essentially we're in the temperature section of the firmware here. So what we've got is, if we go down here, this is what I copied from the example config. So the bed sensor was definitely 99. So if you go up a little bit, you'll see what 99 is defined as. 100K sensor found on some WAN-HAL i3 machines, which fits the bill here, with a 10K pull-up resistor. So there's if I go back to the table here, next to the actual bed temperature sensor here, you get the capacitor and you get the resistor here, and it's a 10K. And there are concessions in the firmware for this so that you get a proper temperature reading. What I didn't realize is there's also a 10K resistor on the hot end temperature sensor. So I originally tried the one that you're supposed to use for the E3D cartridge thermistor, which was number 5. It gave temperatures that were about 10 degrees too high, and that's when I realized that there was a 10K resistor there. So I ended up I tried a couple things first. So I went to 1000 on what I defined it as, and that's a custom thermistor, and I went ahead and I plugged in all the values in the advanced configuration H. Let me see if I can find it here. Of course, there's got to be a ton of values. Okay, so here it is. So these are all the values. If your temp sensor for 0 is 1000, it should use these values. So the pull-up resistor here is 10K. The resistance at 25C is 100. And then these are the beta values and the coefficient from the documentation. So that ended up getting temperatures in line with where they needed to be, but I was getting wild fluctuations still. It was actually 4 or 5 degrees until I changed the configuration H and went to 99. Even then, this screenshot here, this is with 99, and it's still not great. This should be pretty much flat. And the bed also should be pretty much flat. You can see there a little bit of, waviness to it too. So I think what we're going to do here is we're going to end up fixing this to the proper value, which would be 5. And then we're going to end up changing this also for the bed to a proper value, which would probably be, it's going to be one of the generic, 3590, beta things, one of these types of things here. Probably that one. But what we've got to do also is change the resistor on the motherboard. So let me flip back over here. I wish I could show it to you a little bit closer. Actually, I will. Not necessarily in the case though. So what I'm going to do is give me a minute to go ahead and basically label all these cables, and I'm going to pull that board out and we'll get it under a microscope and then swap it out. So let me go ahead and do that, and I will catch you in a second. All right, there's something that I realized before I went to go and put this in the casing. I wanted to adjust the current for the extruder stepper motor since I did replace it from the stock. So what I've got here is the board is still out of the casing. I've got my multimeter with the negative lead hooked up to the negative of the power input. The jumper here is set so it'll receive power on USB. And then I have kind of a cable attached to the end of my positive lead here, so that I can get into the location where I need to place this to measure the what they call the voltage reference, or the reference voltage, for the stepper driver. So I have here kind of the formula. So it's, your VREF equals your current, this is the spec of the motor, times 0.8 times 0.1, which is the resistor, I believe. And this is a divider you get from like the stepper data sheet or something along those lines. So I know this motor is, the current's 1.4 amps. So put that right there. So if I do this math, actually let me flip over and I can just do the math with the calculator here. This is actually where I got the info from for the motor. This was a different motor. Gotta choose the right mouse though, or the right system. There we go. Okay, so that's not the right one. Hang on, calculator. Are you still open? I'm getting confused on what mouse controls what system. There we go. Okay, so what we're gonna do is take 1.4. We will multiply that by 8 times 0.1. So that would give us 1.12 amps, or a reference voltage, if you wanted to operate this at full power, which is the 1.4 amps. You don't want to do that. You generally want to go from anywhere from 50 to like 85%, just to keep the motor cool, as well as, you don't need to drive it that hard. So I generally, when I'm doing motor currents, I set them at 70%. So you just take this and do times 0.70, and you get what the reference voltage should be. So this is 0.74. So if I do this, 0.784. So that's what I get. I should actually do 1.70 just for the percentage. So what I'll do is hook this up to a computer, so it's getting its 5 volts, and I'll measure this, and I'll use a screwdriver to turn the little potentiometer right there, till this reads what I need it to read. Now I've already kind of done this, just in trial, with the motor that's currently on the printer. I had previously swapped out that motor to a bigger one, so this value is probably going to be, I know it's higher than what this is going to be, because I set it for that motor. So we're going to set it back down a little bit, and then we will get it into the case and see if we can get it going. So let me hook this up to the computer. And is this the right cable? Yes. Okay. So let me put my multimeter here to voltage DC. And this is kind of finicky. It's a very tight area to try and get into, but once I see like an actual number here, that's where I'll know where the actual placement is for the part. Okay, so right there, like 952, that's what I set it to before. So I'm going to drop this. So generally they advise you do this with a plastic screwdriver, just in case like you slip and like, hit the board or whatever, but I'm going to be, YOLO. So let's just turn it counterclockwise until it drops. and it is dropping. It's 87, 86, 85. Okay, we're in the 7/6s, and it's a very tiny turn. 7/75. We can go 7/84. Right there. Sorry if my head wasn't. No, my head wasn't in the way. Okay, so that's it. So we'll just pull that off. Turn this off. Let's do it. Pull it from the computer. So that should be the right voltage for that motor. So let's get this hooked up back in the case. Just grab it. Okay. Oh, I probably could have made more room for that. Yeah, let's move all this stuff here. Okay. Yeah, so like all these things, of course I labeled them. They should be pretty easy to put back. Okay. Let's see here. Let's go ahead and put the thing back in. Which one are we using? Let's use that. Okay. Oh, and if you were concerned about my soldering job on that second resistor, come on, focus. Focus. Come on, focus. I redid it off camera, so it's way better. So yeah, this isn't something that if I had done that job poorly, I wouldn't even want to give the system to somebody just to just out of pure safety. But so we'll continue though, and get this thing installed back in the case. There we go, that's a little bit better on the focus. So let's get these screws in. And these screws have a little bit of a, I don't know, like, you probably didn't need a washer this big on it, guys, but they're there, so whatever. They're there. There you go. More. Yeah, come on. That's tight in there. Here we go. And one of the reasons I wanted to swap out those resistors was if I ever do put a clipper on this thing, even though there's a way to account for that resistor being a different value, it's kind of pokey, so I decided to swap out the resistor so I could use just a normal configuration without any weird stuff going on. Okay, so that's that. We can hook the LCD up. Then we'll start hooking cables up. Okay, and I did label them. So Z motors. Let's see. Okay, so this guy, I mean, he was red, so he's a Y motor. There's only one place to put him. So some of them were color coded, some of them were not. So I went ahead and did that. So for example, like the Z motors here, they're white. You got your two white connectors there. Your X motor is a black one, which is this guy. I did label it, but whatever. X motor. X motor. Let's do these Z motors. Let's see. Let's get you two. Is that both of you? So I labeled them Z1 and Z2, so it doesn't necessarily matter their positioning, but I was just going to put them back where I got them. Z1, Z2. Let's see. Okay, so good there. We'll just put on the line. So E motor, that was a funny one. It is actually not like a JST connector. It's like one of these guys where you can actually individually like position the wires. Interesting. So okay, but the motor for sure. So we'll put that in. That's in there solid, right? Okay. Right? Yeah. Okay. So now power. Let's see. So power I had to borrow the connector from. So this goes like this. So ground goes. Okay, so they're going to go in like this. So I've got to place them back. So I have to go. Wait, hold on. They go like this. Right? Yeah. Yeah. So ground is going to go into this one here. And then the voltage is going to go there. Come on. That's where you go. I need to open it up a little bit more. Let's see. Well, let's get the ground one tightened in where it needs to go. So. Enough for now. There, and we will loosen the voltage one. Oh, hey, why did you do that? That doesn't seem right. How are you? Maybe I put it under. Let's try that again. What is going on here? What is happening? Let me take a look at this. Okay. So yeah. Oh, I was putting it in the wrong place. It's got to be open. Okay, so again, we're going in like that. The ground again needs to go here. I actually tighten it. Yeah, we'll tighten it up more afterwards. And then let's see. Come on, power. Get you out of the way. Oh. Here we go. And these. Give a good little crank. Yep, should be good. Let me plug it in. Make sure again, according to the board, ground is here, voltage is there, good. Let's see, that's hot end. Let's see, that's fan, that's other stuff, that's other stuff, that's other stuff. We need a heat bed. Just kind of going down the line here. Heat bed, in there. What's next? Hot end. Let's see this. Let's see. So this is a fan. This here is the hot end. So HE. There you go. Fan, I know is this guy, because it says fan on it. Right there. Yeah, you're good. Get in there. Okay, that's the fan. Now we got the XYZ stops. Oh, dang it. I didn't think about that. So one thing I didn't do is I didn't realize that there were, for the temperatures, 2 of those have the same color as the stops. Dang it. So I guess I'll have to do a little bit of work on that. Hang on a second. Let's see. So the red one's definitely the Y stop. So that's easy enough. Okay. Oh, that's easy. Okay, that's easy. The white ones are the temperature sensors. That's right, that's right. Okay, so this one should be the Y stop. This one should be Z. And I go here. And then your temperature sensors, they are color coded. So just like so. Okay, I think that's it for that. Let me flip over to the screen here and let's do the firmware stuff. Let's see. Okay, so this is the E3D thermistor that's on the hot end. So let's go down here. So that was 5, so temp sensor 0, 5, and now we can no longer use the 10K ohm one for the heat bed, like this guy here. So we're gonna go. Let's see. No. That's a 10K ohm. Ew. Or yeah, 10K ohm. Let's see. I wonder what other people have used. Oh, well, look at that right there. I was looking at it. Most of mine have i3 machines. Beta 3950. Okay, so 11 is going to be for the bed now. 11. What else? I wanted to check. I just wanted to check the size. Okay, so that's all still good. That's all still good. So file save. Let's go here and we will build it. And we will let that go. Actually, while that's building, I can't have the LCD in, so I went ahead and unplugged that. And then this thing is on 5-volt power. That's good, that's good. Let's see. There's that USB cable. Where did I put it? Oh, there it is. So while it's building, I'm going to go ahead and get it connected to the computer. Might as well put the SD card that I had in there back in too. I don't think it really matters. Like, I don't really plan to use anything off the SD card. That's the way it goes in, I'm not sure. Yeah, it's got to be upside down like that. Okay. Yeah, okay. Well, let's plug this guy in. Yeah, if you take it while we're waiting on that, oops. Take a look at some of the prints that I've done. Let me see if I can pick up the first one. Yeah. yeah, so this here, this was the first one. There were some, let's see. This one, I mean, it stopped extruding like right in the middle of it. And then as I was tuning the slicer profile a little bit, like it got better and better. You could see kind of here, I think this one is probably under extrusion due to the motor current as well as the temperature. It's voids in it. This one's even worse, as you could probably see the voids in it. But I slowed, as I slowed it down and kind of tweaked the temperature just a little bit more. I mean, they got better and better. So I'm hoping this will kind of resolve them all. And actually, you know what? While we're waiting too, let me unplug that extruder motor again, because I want to swap out the actual motor on the Titan here. Back to the original one. I could use that motor for something else. It's building. So can I do this? I could probably do this without. Man, maybe not. Well, we'll see how far I can get with the filament in there. And one other thing that I actually noticed, filament's in the way. You know what? Let's chop it. Oh, you're not still seeing much, but. All right, so that's done. Let's go ahead and upload it. And we'll just continue with this motor swap. Okay, let's see. Oops. Yeah, I guess I'll have to heat it up and pull it out. Maybe not. I mean, can I just do the whole hot end? I can just do that. Look at that. Okay. Yeah, we can do that, I think. Let me just kind of tweak that out of the way. It's still building anyway. Almost from my. Okay. So let's put this back together. Where did the little motor go? There it is. Okay. So the little motors, you can see like the difference in them. Back there, where it was. Oh wait, I need to do the screw even. The gear. So let's see. That's too small. How about you? Okay, we're still up. We're still doing it. Okay. So that's off the big motor. We'll put that over there. And again, where did I set the logo? There we go. Okay. So let's reassemble this. And if I recall, this thing was like barely away. I mean, I'll tweak it to make sure it actually goes where it needs to. Like so. Oh, come on. Around 5 volt. I don't have the reset jumper on, that's why. I need the reset jumper. Try that. Dang it. Failed. I didn't get it in time. Okay. try it again. I'll just hit upload again. Okay, let it go. Okay, so actually, looking at that, I think it's aligned pretty dang good. So let's just go with it. Let's put this guy back on. Okay. Yeah, I think we're good. Let's make sure to get that in there. Let's see if we can get all this back together without having to like mess with it. Not bad. Not bad. We're getting there. Getting there. There we go. I think we're good. Let's get this guy on. Yeah. Yeah, we're getting there. We'll put the lid back on. There we go. Yeah. And we'll just put it back again. Is it still? It's writing now. Okay, good. Okay, it's doing it. It's doing its thing. All right, that's done. Let me just finish this. Then that gets barely tightened. Okay. All right, so looks good, looks good. Looks good to me. All right, that's all happy. Let's kill this. Unplug. Move the jumper. Plug the extruder motor back in. I think that was it. Actually, there we go. Snapped in now. Okay. Man, that board really bowed. Move that jumper back over. Try it again. We didn't get it. Nope, still didn't get it. Wait. Yeah, we did. Dang it. I'm messing this up pretty bad. There we go. Okay, so resets off. Back to voltage. Put the LCD back in. Okay. I think we're good there. Let's just do this. We will plug this into my Raspberry Pi and turn it on and hope it doesn't explode. Come on, focus, thank you. All right. Oh, I gotta plug it in. Dirt. Hang on. I was wondering why it wasn't coming on. You gotta plug it into the actual power. Let's try that now. Here we are. Okay. Moving up. Temperatures look the same. Here, let's do this. Now we'll flip those. Let me open the web interface. There we are. So 23, 24 and a half. This looks pretty good. Let's turn on the bed. Get it warming up. And let's do the hot end too. We'll do 220. While we're doing that, let's just double check those end stops real quick. 119. So they're all open. Okay, good. Let's try Z. Triggered, good. We'll try X. Triggered. And we'll try Y. Triggered. Okay, end stops are good. Let me remove the tape that I had over here. Okay. X. Well, home X. Looks good. G28Y. Also good. Let's not do Z yet. Okay, so I want to watch this temperature here. So this thing like overshot massively. So we'll go ahead and we'll give it a minute to get up to temperature, and we'll see how it goes. I think we're ready. So I've got my cube here. I'm pretty sure I'm gonna have to baby step Z on this, but let's print it. Okay. Come on. Maybe I need to go down. That first layer is crap. Well, you know what though? I'm gonna let it go because it's sticking to the bed, and I just wanted to see the later layer. So we're gonna go ahead and let it go, and I'll check back in when it's done. Let's do that. Catch you in a bit. Take a look at that. It's finished printing, and we will take it off the bed and take a look at it. So let me go ahead and pull this off here. Okay, it looks pretty good. Let me see here. Let's go ahead and put that back on. Like so. Put these clips back in place. Now let me go ahead and pull that skirt off of the build plate real quick. Just get it out of the way. Let's see if we can take a closer look at this thing here. Come on. Okay. Not too bad. I do see kind of like a little void there. Not too sure. I was actually watching it during this part. It didn't look like the extruder skipped steps or anything like that. So I wonder if this is maybe more just kind of a temperature thing. Or maybe it's, you know, maybe the power supply is a little bit underpowered. But I think I'm going to call it good. This is definitely the best one that I've gotten so far off of this machine. I'm going to call it all taken care of. So I think what we'll do is just close this up and close out the video. So let me go ahead and shut it off. Let's see, let's disconnect this. This is all good. Let's see if we can get this all back in here now. pull that power plug in. Let's see. And pretty good. Pretty good. Let's get those cables in there. We'll get the bottom kind of attached to this. Let me grab a screwdriver. Let's see, I think it's you. We'll grab the bottom. Yeah. Then let's see if we can get the power supply line back up again. Kind of like so. Let's see. There we are. Let's see if we can get that far opposite corner. Come on. There we go. Here, at least now I don't have to hold it. Let's see. These two screws in. So. Okay, now that that's kind of in place, let's go through, we'll get these guys taken care of. Wait, that's too small. How about you? Come on. Try that again. You gotta line up, right? I might have to loosen up one of these other guys real quick just to get that one in. Here we go. Two more on the bottom, and then we'll get the back on. Okay. Let's get the back on. Like so. That's on. Yeah, that's good. Try not to pinch any of the wires. Come on. Here we go. Focus, thank you. All right. Let's go ahead and put it back like so. We will plug this in again. There we go. Straighten this up a little bit. And let me grab a camera real quick, and we'll flip over to another view, and I will turn it on. Let's see here. How do I want to do that? Oh, you're going to see my OBS setup in the background, so here we go. I just realized as I was editing this video that I didn't include the fact that everything that I did didn't actually fix the temperature graph. I mean, the resistor change, the firmware updates, none of that. So I think this is probably power supply. I do notice that it does kind of start to go wavy like this when I turn the bed on. And I don't think it's fan, because I've run this with the fan disconnected. So I'm pretty sure this is just weak power supply. I'm not really going to do much about it at this point. I mean, it's printing well, so I'm going to leave it alone. And let me flip over to the table view, and I'll get you a shot of the printer. And here we are. Come on, go ahead and focus. So here's the completed printer. Let me go ahead and turn it on. Can we get anything out of this, or is that just too bright? Okay. Well, in that case, let's do a home. We will home X. Do home Y. And might as well go for Z2. Once it's there, let's go ahead and move this thing. We'll move it to 50. And then let's move X to nil. And we'll do Y to the front. There we go. All right. Well, there you have it. If you made it with me this far, I appreciate it, and I want to thank you for coming back for the third part of this. This is truly the end of the actual series, so if you would, like and subscribe, and I will catch you in the next one. Thanks. Bye.